Hi, this screencast is to help you with starting the homework assignment. We will do it by asking questions that can be posed at the early stage of the week after your initial review of the lecture and the homework problems. We start with problem 1. A fair coin is tossed 8 times. Find the probability of obtaining A, exactly 6 heads, B, at most 4 heads, and C, at least 5 heads. Let us move directly to the suggested questions. The first. What is one general question, answering which would answer all 3 questions? Indeed, there are apparently 3 questions dealing with 6 heads, at least 5 heads, at most 4, so maybe we need 3 different equations. Now, here is the question. A coin is tossed n times. What is the probability of m heads? Naturally, knowing this answer would answer all 3 questions. Second question. Can you ask this question in even more general form? Yes, we can. Consider a random experiment with 2 outcomes, success and failure, 0 and 1, heads and tails, win or lose, etc. From the lecture, you can learn that these experiments are called Bernoulli trials. So, the most general question is, what is the probability of m successes in n Bernoulli trials? Sounds a little weird, but this is indeed a very general question related to our problem. The trials, by the way, are simply the repetitions of Bernoulli trials. Question 3. Which part of the lecture addresses the Bernoulli trials and related probability distributions? Well, you can go through the lecture and you find that this is section 2.1. So here's the link. We can click the link and we will see the chapter. And here are 3 probability distributions. We see binomial distribution, geometric distribution, negative binomial distribution. All 3 are based on the same Bernoulli trials. However, the experiments answer different questions, and therefore the probability distributions are different. So, find the right distribution that answers our general question, and the problem will be solved. Now the problem 2. A head contains tags numbered 1, 2, 3, 4, 5, 6. A tag is drawn from the head and replaced. Then the second tag is drawn. A. Show the sample space. And B. Find the probability of the event second greater than first. We call it SGTF event. Here are the questions to ask. First, what are the elementary outcomes of this experiment? Okay, you may say the tag numbers are the outcomes. However, this is not exactly correct. Why? Well, here is the hint. What is the outcome of the experiment of rolling 2 dice? Is this a number on the face? Remember, we built this space in the lecture 2. Second question. How replacing the removed text can affect the sample space of the experiment? What is the major difference in terms of the outcomes between the experiment conducted with and without replacement? Do they have common outcomes? Which sample space is larger? Probably you have a hunch that replacing something that has been removed increases the size of the sample space. Is it correct? Please think of this. Third, let us start thinking of the SGTF event. Which outcomes contribute to it? Are there any contributions with the tag 1 equal 1? How many? What about tag 1 equals 6? In general, how many contributions correspond to tag 1 equal m, where m is 1, 2 through 6? Thinking of this will help you to describe the union of 6 complex events, each of whom is the intersection of 2 events that will lead to solution. Okay, problem 3. 6 students, 3 boys and 3 girls, line up in a random order for a photograph. What's the probability of the event A, boys and girls alternate. Hint, please use the formula for the probability of the event A equals number of outcomes belonging to the event A over the total number of outcomes. And our further discussion will be mostly about how to find the number of outcomes belonging to the event A. Boys and girls alternate. How to count all the outcomes, not to miss anything. Some advice. Remember the rule, narrow your mind. Here it is. Please read about this rule in the lecture. What does this rule mean? It suggests you, in order to determine an A, focus only on the outcomes belonging to the event A. What are the outcomes? To enlist all, we can distinguish between the macro outcomes and micro outcomes. The example of a macro outcome, which is actually a group of outcomes, is BG, 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 boy, girl, boy, girl, boy, girl. We see that boys and girls indeed alternate in this macro outcome, but we do not see their faces. So it's called macro because it does not distinguish between individual boys and girls. Are there other macro outcomes in this problem belonging to the same event? You have to answer. Each macro outcome includes a number of micro outcomes. For instance, the same arrangement BG, BG, BG includes the sequences. The boys and girls are now numbered B1, G1, B2, G2, B3, G3, and the sequence B2, G1, B3, G3, B1, G2, and so on. So now they have numbers, they have faces, and we can see that macro outcome is a group of outcomes corresponding to different arrangements of the boys and girls within the same pattern, BG, BG, BG. So how many micro outcomes in each of the macro outcomes? This is for you to find out. Now we should be well equipped to solve this problem.